So today I'm going to talk to you about the science of vaginal odor and BV. My name is Kevin Tao, and the reason I can speak about this is because for the past 13 years I have co-founded a company called New Eve with my mom, who's a gynecologist. We have helped tens of thousands of women resolve their vaginal odor issues. My mom, she was a researcher, gynecologist, did tons of research all around women's health. Me, I attended Duke University, studied biomedical engineering, and we have a lot of expertise in this area. So I'm going to teach you all about bacterial vaginosis and vaginal odor, and by the end of this talk, you will be an expert at this as well. Overview of what we're going to talk about today. First, we're going to talk about what a normal, healthy vagina looks like when it comes to the vaginal microbiome. We're going to talk about the ways in which it gets out of balance. Why does it get out of balance? We're going to talk about how BV happens, the mechanism behind BV, and then we're going to talk about the various treatment options that there are, as well as how our treatment option is unique and special, and it can deal with it from a very different angle than everything else. All right, let's begin. So, how does a normal microbiome look? Well, a normal vaginal microbiome, let's draw the vaginal canal like this. So a normal vaginal microbiome has bacteria living inside of it. These bacteria are called lactobacilli. These are the same bacteria you're going to find in yogurt, in cheese. These bacteria eat lactose and they produce lactic acid. So these bacteria, they prefer to live in a low pH environment. pH is a way to measure acidity. So these guys like it to be low pH, and they also produce a lot of acidity itself. So they like it when it's low pH, and then they also create acid, which makes it low pH, so it becomes a cycle. So the best analogy I can use to describe how lactobacilli works is a little phenomenon that happens in Illinois. So the place that our headquarters is, the place that I grew up in, the native lands here were prairie grasses. And lactobacilli are very, very similar to prairie grasses. So if you know anything about how prairie grasses work, prairie grasses are very special. So they're grasses that grow very tall, very fast. Once they're finished growing, they actually dry up. When you have a bunch of prairie grasses that are dried up everywhere, is that it's very easily to light on fire. So imagine you have a bunch of tall grasses like this. How do prairie grasses survive in a world where there are trees that are big and blocking out the sun, and there's all kinds of other weeds and stuff? How is it that prairie grass is able to maintain a certain dominance of prairie grass in general? Is that prairie grasses become dry, and then once they become dry, they become easy to light on fire, and then once everything's on fire, the prairie grasses will light on fire, the trees will light on fire, the weeds will all light on fire, right? And then after the fire has swept through an area, prairie grasses are the least susceptible to fire. They love being on fire. They don't care if they're on fire or not, but they spread fire around, whereas everything else, the weeds, the trees, all kinds of other stuff, they get burned up by the fire. And lactobacilli work in a very similar way, where if you only have one prairie grass, it's not really going to create the fire that you really need to keep out all the other stuff, right? Just like with lactobacilli, if you only have a small population of lactobacilli, it's not going to create a lot of lactic acid, which isn't going to end up killing everything else. But when you have a lot of prairie grasses, you have a lot of lactobacilli. So prairie grasses use fire to kill everything else, which keeps the dominance of prairie grasses. Lactobacilli use acid to go kill all the other bad bacteria that could get involved in the vaginal canal. So what a healthy vaginal microbiome looks like is dominated by lactobacilli for the most part. There are some exceptions. We'll get to it in a later video about what happens if you have way too much lactobacilli. It can cause problems. So let's talk about what BV looks like, bacterial vaginosis. So what's happening in bacterial vaginosis? In the vaginal canal, there starts to take over, the most common species of bacteria that will take over is called Gardnerella vaginalis. Gardnerella vaginalis. There's a couple other ones, Atopium vaginae, Prevotella bivia. There's a bunch of them. The main thing that all the BV bacteria have in common is that they are anaerobes. That means that they do not like oxygen. They do not like air, right? They're anaerobic. And they do not like air, and also they do not like acid. This is the bacteria that produces fishy odor. It produces a gray discharge. And as a matter of fact, at any given point in time, right now in this moment, about 30% of women, of all women, have BV at any given point in time. The typical thing that triggers this is when the pH, so a normal healthy pH is going to be around 3.8 to 4.5. That's if water obviously is at 7 pH, that's neutral, right? The healthy vagina's pH is in this range. If you want to imagine, basically this amount of acidity is how sour, for instance, an orange is. It's not super sour, but it's medium sour. This is an orange level of sourness. Typical things that will trigger BV to happen, interestingly enough, triggers of BV, any time the vaginal pH becomes basic, right? And it happens actually very often. One common trigger is your period, because blood is actually alkaline. It's slightly above 7. Another thing that triggers BV is sex, because semen is also alkaline, and also saliva. Semen, saliva, these are all alkaline things. So if you're someone that has BV, you've probably noticed that right after your period is when your BV might come back, or right after having intercourse, your BV is coming back. These are just common bacteria that happen to be in your vagina often. When the acid rises, these guys are very unhappy, their population goes down. And when the acid becomes weak because of various events that happen, they come back. The other thing that, there's one more thing that often is very related to BV, which is menopause, as well as postpartum after you're pregnant and you're breastfeeding. And the reason why menopause and postpartum are related to BV is actually because of hormonal changes. In those times, your estrogen is decreasing. In a previous video, I kind of explained this. The normal healthy vaginal canal is very thick and wavy and has many, many, many tissues and very healthy blood vessels feeding all of these tissues. When you have 50 layers of tissues like this, it's very common for exfoliation to happen. So exfoliation is similar to when your skin exfoliates, right? You have healthy skin, you're constantly growing new skin, and so your skin's gonna flake off at the top. These dead vaginal lining cells will flake off, and when they flake off, these cells become food for good lactobacilli. So in the time of health, you have high estrogen and thick vaginal walls. Lots of exfoliation means food for lactobacilli. Lots of food for lactobacilli means lots of lactic acid, which is a low pH. When the reverse happens, right, when the estrogen decreases, the vaginal lining shrinks. There's less new vaginal lining being made, there's less blood flow to it, there's less exfoliation of the cells, which means there's less food for lactobacilli, which means there's less acidity, and less acidity allows the anaerobes to rise. And that is why these are the most common ways that this kicks off. That's a lot, but I hope you guys understand. If not, I'm sorry. This is the best I can explain it. So let's talk about now the various treatment options you have for bacterial vaginosis. So the first treatment option that is super common, douching. There's a lot of versions of douching, right? There's douching, there is boric acid, there's feminine wash. So douching is one option. Another option is antibiotics. The idea behind douching, boric acid, feminine wash, anything like that is if you think about what is causing the vaginal odor, right, is this bad bacteria, Bacterial vaginalis. So let's just kill it, right? The main mechanism it works is just kill bad bacteria. That's the idea. However, all of these things, this stuff works and it's gonna work fast, right? Whatever's directly causing that bad smell, immediately it's gone, right? So the benefits is that it works really quick, right? You smell nice fast. Unfortunately, the question is, what comes back? What grows back? Well, what grows back is random. It's basically whatever the first bacteria to come back is. It's, I guess the analogy I would use here is, let's say you got a tropical island like Hawaii and it's overrun by chickens that are just annoying. There's just chickens everywhere, right? And you want to get rid of all the chickens on the tropical island. Well, one option is, why don't we just nuke the whole thing, right? That's what this is saying. There's trees here, there's grass here, there's little cats and dogs and people, but we're really annoyed with the chickens because they're just everywhere. So let's just throw a giant nuclear bomb and just blow up the whole thing. And so now you got an empty island, no chickens on there, right? They're solved. But then as soon as the toxicity is gone, what's gonna come back? Well, what comes back is just whatever birds fly over the island and whatever seeds they drop, or whatever new birds like land here, or whatever gets brought by boat. It's kind of uncontrollable what grows back because it's just going to be random, right? And funny side note about boric acid. Boric acid is also used to kill cockroaches. So cockroaches are this insect that it actually survives nuclear bombs, right? When you nuke things, cockroaches don't die. Everything else dies, but cockroaches live. And boric acid can kill those cockroaches. So if something is even deadlier than a nuclear bomb, is that something you really want inside of you? Up to you, right? It's a free country, do whatever you want with that knowledge, but do be aware that boric acid kills things that nukes don't. So that's the benefit of douching boric acid feminine washes. Works super quick, but the downside is you have no control over what grows back. Sometimes it'll grow back perfectly fine, sometimes it just won't grow back the right way, and then you have to use it again and again. So option 2 is antibiotics, right? In antibiotics, there's some common ones. There's metronidazole, that's one of the standards. There's also secnidazole. There's a couple other ones. The main idea with these is pretty similar to douching. It's similar idea, but a little bit different. So what's going on with antibiotics? Here's an analogy I'll use for you. Imagine you have a killer robot that you can program the code for. Your goal is to kill all people, but keep alive dogs, cats, pigs, cows, chickens, birds, just everything else. You want your killer robot to only kill humans, but keep alive dogs, cats, pigs, birds, etc. You can give your robot any commands you want, right? What command would you tell the robot to do to figure out what to kill and what to leave alive? You might tell your robot, look and see what has 2 eyes. But then if you tell it to kill everything with 2 eyes, it's going to kill dogs, cats, pigs, cows, and birds. So that's not going to work. Well, what if we say everything that's a mammal? Well, that's not going to work because then it's going to kill people, dogs, and cats, and all that. So what if we say we'll kill everything with 2 legs, right? Well, then it'll kill all the people, but it will kill all the birds too. So your killer robot is going to have some rules. It's going to be, okay, we got to kill all people, but how do you know it's a person? Well, it's got to be 2 legs, it's got to be a mammal, and that'll mostly get the job done, right? It'll kill the people, but keep alive dogs, cats, pigs, cows, and birds. So now you set your killer robot loose. And let's say you set it loose in the entire city of, let's say, Chicago, where we live. Is it going to kill every single person in Chicago? Well, if you give it these rules, it will kill 99% of us, right? It'll kill 99, maybe 99.9%. But there's some people in Chicago that have one leg, right? And so it's going to leave the one-legged people alive, right? And these one-legged people, they're going to wake up and they're going to see, holy cow, there's all this food that's left out to be eaten. There's all these fancy houses, fancy cars, everything's available to me. And the one-legged people who survive, they're going to reproduce a lot, and their population is going to grow really, really big after a while. This is how antibiotic resistance happens, right? So with antibiotics, you are targeting these bad bacteria, or you're targeting bacteria in general. You're going to kill the good bacteria and the bad bacteria, but you're skipping out on some other things, because the way that antibiotics work, the reason why it can kill only bacteria, every antibiotic is targeted in such a way. The problem with targeting is that it's never 100%, right? Even if you make this more specific, you say kill everything with 2 legs, a mammal, 2 eyes. You can use multiple things at the same time, but this is why there's antibiotic resistance, because something's always going to survive. There's always going to be some random bacteria with a random mutation that is going to survive, and it's going to grow. So let me explain to you how New Eve works. So what we do differently is this, right? We looked at what everyone else does. We looked at how boric acid works. We looked at how antibiotics work. Let's think about this. Let's just take a step back and really think about this. The mechanism of how a healthy vaginal microbiome works it's a pretty good mechanism. We don't want to necessarily use targeting to just kill the bad guys, because that's not going to do it. And we also need to support the good guys. So here's an analogy I want you to think of. Imagine you're back in World War II. At the part of World War II where France has been conquered by the Nazis, for instance, right? Here's the Eiffel Tower, here's a bunch of Nazis. So you got some bad guys, and then you got some good guys. You got your resistance fighters. There's a French flag right there. You got some bad Nazi guys, you got some French resistance fighters, and how are you going to liberate France, right? You can't just nuke everyone. And even if you just drop a bunch of bombs on only the Nazis, it's going to finish the job, right? You can weaken them and then they'll just come back, right? So what we do is, first of all, we use pH control to make life as pleasant as possible for the good guys and as unpleasant as possible for the bad guys. We use pH control, and we use a lot of botanical nutrients that antimicrobial against bacteria, right? So we use pH controls, we use botanicals. This is basically targeted only against the Nazis, and at the same time airdropping nutrients for selective feeding to our allies. So imagine airdropping a bunch of croissants and baguettes, right? Because the French love they love their croissants and they love their baguettes, and they're our allies and they need pork, right? And they don't like that stuff. Our allies like that stuff, right? We're not dropping bratwursts and sauerkraut, right? We're dropping just our allies like to eat. When you do this, right, you're boosting and supporting the good lactobacilli, while at the same time making life really unpleasant for bad guys. And we found through helping tens of thousands of women that when you combine this together, right, the problem with all these other methods is that, work, yes, of course it works fast, but it doesn't last. It doesn't finish off the bad guys. It just weakens them and then they come back. Whereas when you build up your allies, you build up the population of good lactobacilli, and it performed, once you get enough good lactobacilli going, they produce lots of lactic acid, and they keep out all the bad guys forever after that point, right? One more step here that I wanted to mention is that we introduce, because obviously, the way we defeated the Nazis was we also supported the resistance fighters, and also we landed on the beaches, and that's also part of our program too, which is we introduce probiotics to the vagina. After using this called BV Clear, once every night or once every other night, depending on how severe things are, and in between, you're inserting a vaginal probiotic pill into the vagina. The pill is filled with good lactobacilli, and those good lactobacilli are going to colonize and fight back against the bacteria. Basically, beach landings at Normandy. We gotta storm the beaches. Bonus thing about how New Eve works. Remember I was talking about what causes BV for postpartum. After menopause and postpartum, the vaginal canal itself becomes very thin, and the blood vessels running to it are also very thin and not exfoliating as much, right? So if you remember that, what New Eve does additionally is that it nourishes the vaginal walls, right? When you have BV because of this reason, New Eve does is as a suppository and as a salve that's applied from this direction as a suppository filled with nutrients coming from this direction, and then as if you take all of the supplements as part of our kit, what is happening is that it nourishes the wall from all different directions to bring back the thick vaginal wall with lots and lots of good blood vessels feeding nutrients to it. When you restore this, exfoliation's happening again, and the exfoliation in this analogy over here, like it is the croissants and baguettes. So this, when you restore this, it back all the lactobacilli, and then it ends BV permanently in this other mechanism. So just wanted to finish off the ways that New Eve fights BV from every possible angle, unlike these other things that just finish it, attack BV from one angle. If you would like to try New Eve, it's only cheap, it's only $39, and we have a guarantee that it's going to work. We have a guarantee that it's going to work way better than anything else you've ever tried. Thanks for listening to my talk, and let me know if you have any questions. We're happy to help and answer. And if you see this and any of this inspires you, our company, our mission is to transform women's health through leading from the front, through bravery, through kindness, and through curiosity. So we are recruiting people, and if you believe your talents could be helpful here, know as well. When I say leading from the front, what that means is that my mom, the gynecologist, Dr. Chang, tests everything herself. She does every single manufacturing run. She talks to all of our customers, and she's inventing all these things, and so am I. I'm hoping to follow in her footsteps, and we're hoping that other people follow in our footsteps, and together we can transform women's health. The stuff I'm teaching you guys, it's not rocket science, right? But there has been a lot of misconceptions and misunderstandings, but I have found that as long as you just ask the simple questions of why things happen, what is the mechanism of different things, it's possible to make huge breakthroughs that end up helping tens of thousands or even millions of people. Right now, in this moment, 30% of women worldwide have this. There's 1 billion women suffering from this right now. If we can help some of them, that would be amazing. We could make a big impact on the world that way. Thank you so much for your time, and I hope you have a really good rest of your day.